Okay, so the old way of doing things, a GPU would, move some data from its main memory to its super fast on-chip memory, do a calculation, and then wait. Then it would move the next chunk. Lots of waiting around. Warp specialization completely changes the game. It creates these specialized teams of workers. One team is only responsible for moving data, while another team is only responsible for doing the math. And this is the perfect way to think about it. Instead of one person running back and forth from the pantry to the stove, you have this perfectly coordinated kitchen. The sous chef is prepping the next set of ingredients while the head chef is busy cooking the current dish. There's just no downtime. Everything is always moving. Now, the second trick is something called asynchronous pipelining. The attention calculation has a few different steps. There is a really fast number crunching part called matrix multiplication, or GEM, and that's followed by a slightly slower organizing step called softmax. What Flash Attention 3 does is just genius. It cleverly overlaps these tasks. So while a slower calculation is finishing up for one block of data, the fast matrix multiplication for the next block of data is already starting. And that's the whole point, really. This overlap effectively hides the slowness of the slower parts. The GPU's super powerful computational units are never just sitting around waiting for something to do. It's a continuous, overlapping flow of calculations, squeezing every single last drop of performance out of the hardware.
Okay, so what's really fascinating about this next part is how they found yet another way to basically double the speed of everything, but it came with a huge risk, potentially losing accuracy.
This technique is called FP8 quantization. The easiest way to think about it is like using a lower resolution image. You can store it and process it way faster, but you might lose some of those important details.